Hey, so I realize it's been a while since I gave literally any updates on the PyKrasue project. I sort of left it. I made some stuff and then I left it and didn't do anything. But I've been chilling today and I've done some stuff. So TLDR, here's the situation. I've got 2048 objects. That's about as many as I can. Ooh, we're down a little bit, 20 frames per second. Okay. 2048 objects in Pygame, 20 something frames per second. Okay, so in PyKrasue, we're looking at about 300 frames per second. Plus, this supports arbitrary sort of arbitrary transformations. So, what has happened? A few things, maybe three things, or four. One is, as you can see on the side, I've switched the project over to Pygame. Now the reason I did that, used the Pygame to beat the Pygame. No, it's just that Pygame has much wider support, and when I was doing benchmarks on different systems, I was having issues with systems supporting Pygame but not supporting GLFW. So Pygame is there just to get the window up. All the work is being done on the GPU. Another thing I've done is I've just been using these little tidbits of wisdom, these little gems that I've been learning. One of them is data compression. So I've been representing my vertex data with a smaller number of bytes. I'm just using half precision floats. So another thing that I've done is I've implemented a texture atlas system. So at the moment, I've got a texture array, which you can think of as a bunch of individual slices. Every slice holds a texture. And this is fine at the moment where we've got like 20 something textures. That's okay. You can have 20 something array layers. That's fine. But when at a later point I bring in animations and stuff, then it could be a whole lot of little tiny images that get loaded in. And I think it's sort of wasteful to dedicate a whole array layer just to a tiny image. So I've got this system where we have I'm calling them texture pages. I'm taking a leaf out of Game Maker's book and calling these texture pages. But I've got these like 4096 by 4096 slices. And as images are thrown at the texture atlas, they are progressively slotted into a slice. So we attempt to find a rectangle which has not been allocated, which can fit the incoming image. And if one exists, then we subdivide that image and put it in. And if one does not exist, we put in a new texture page, subdivide it, and so on. And we can actually go over to the build code and we can save back. So then I'm doing some other tricks here where I am blitting the individual images back to those actual texture pages and then blitting the texture page into the array layer. And the benefit of that is we can save the texture pages. So this will take a little bit longer, but we can then go and look at the texture pages. So this is how the program has dynamically stuck these images together. And it just cuts down on the texture usage. So then the other thing is, if we look at these textures are actually really big, and what's being drawn on the screen is actually really small. So the last feature that I implemented is MIP mapping. And that's very straightforward. The only thing I need to do there is, after I've gone through and made my texture, I just make sure to select a MIP map based minifying filter, then generate a MIP map. And really, truly, this is the thing that makes the massive difference. So if I were to comment this out and do the whole thing again, then I'm pretty sure that the tricks I've done so far would improve it a little bit, but oh, it's a little better than the Pygame example, but it's only 30 frames per second. So clearly oversampling the textures is a massive problem, and it just doesn't need to be that way. So yeah, there we have it. What do you guys think? Is this entertaining? Are you not entertained? We have 2048 sprites, and we've got 15 times the performance of Pygame, and we're using Pygame. I don't know. Maybe I should get out more, but I find this very, very cool. So what I'll be doing for now is I'll be implementing this, or first up, I'll be building this, uploading it to pip. You'll have access to it. But I'm also going to be implementing an ASDO, approaching zero driver overhead renderer, to do the same thing, but use things like storage buffers to further cut down on data duplication. But yeah, this is my long talk. Thank you for coming to my TED Talk, and I will see you again soon. Bye. Hello, how's it going? I know it's been a while since I've done one of these Patreon readouts. It is not super fun watching the numbers go up, go down. It's like a health meter in a video game, except it's real life. But I am community supported, and you guys are salt of the earth. Everything you give, like it does. I know I sound sick. I'm not putting this on. I really do appreciate it. It's very cool. Thank you, my dudes. If you would like to support me, it's $2.50 a month. No more, no less. But without further ado, really big thank you to Antonin Carret, Declan, Endelon Studios. Sorry if I say this wrong. Juan Valsvilla. Sorry. Mathieu Duric and Moim. Thank you so much. It really does mean a lot. And yeah, here's to many more happy times. All right. Cheers.